Good afternoon, everyone. Thank you so much for joining us. My name is Katie Poser. I'm the Outreach Librarian for the NOAA Central Library, and I will be your technical host today. So welcome to our first seminar of Responsible Use of Metrics Week. Many of you may have been seeing our emails this week, and we will be continuing to send emails through the rest of the week. And we do have one more seminar called Responsible Use of Metrics on Thursday, which I will definitely promote at the end of this one. But today's seminar is Meet Your Metrics, Bibliometrics 101. Our speaker today is Shinn, who is the Metadata and Public Services Contract Librarian from MPF-ZAI Solutions, who will be giving this presentation on the NOAA Central Library's Bibliometrics service and more. I won't steal her thunder or the agenda that she has prepared, so I'm going to turn it over to Hope.
All right, thank you, Katie. As Katie said, I am a librarian here at the NOAA Central Library, and I do a lot of different things, so you may have also seen me in other capacities, like with the research service and all that. But I'm here to talk to you today about bibliometrics. Here's just a brief look at our agenda for today. I just want to make it clear this is not a comprehensive look at all possible metrics or measures used in bibliometrics. Rather, this presentation aims to introduce the concept of bibliometrics, what it measures, why we use them, and how they're used. So, and then at the very end, I'm going to talk a little bit about ORCiD. ORCiD is related to bibliometrics, but it's also something that we're really emphasizing here at the library, and hope you all use it after I talk about it at the end of the presentation. All right, starting off, what is bibliometrics? Bibliometrics is a quantitative analysis of academic publications used in an attempt to provide better understanding of the research we produce and how it is used, especially in terms of quantitative measurements. The question of how good someone's research is very nebulous. It's very abstract, but bibliometrics tries to put numbers to it. As a field, bibliometrics emerged as an objective way to measure the quality of someone or some things' publications. So that could be anything from an individual researcher all the way up to a huge organization such as NOAA that employs a lot of researchers and also funds research. And it can also apply to other kinds of entities in scientific publishing, such as scientific journals. So I just listed some examples on this slide of bibliometrics measures you may have heard of. Citation counts is a pretty obvious one. Pretty much everyone who's published a journal article is interested in who is citing them and how many people cite them. But there are also more in-depth metrics, such as the H index or something like journal impact factor. And I will get into more detail about all of these as we go. So we kind of think of bibliometrics as broken up into three different categories. The first category here is productivity metrics. These are the most straightforward. These are your straightforward citation counts, the number of articles produced by an entity in a particular amount of time. There's not a lot of calculation or computation that goes into these numbers. They're mostly just counts. The chart here is an example from one of the reports that we've done for ocean exploration. So you can see it's just a straight reporting of the number of articles published per year from 2002 all the way up to 2022. The second category of metrics are performance metrics. This is where it gets a little bit more complicated. Performance metrics are where we try to get into questions of quality. So these typically involve some calculation with productivity numbers. One common example is H index, which I'm sure many of you have heard of. It's a metric for individual authors, and it's calculated by taking the number of papers that the person has written along with the number of citations those papers have received. And the actual H index is the point at which those two things converge. So to put it in really concrete terms, because I know that's can be kind of confusing, an author with an H index of 10 has at least 10 papers with 10 or more citations. And the idea here is that the more papers you publish, the more citations you get, the higher your H index is. So if you hear that such and such an author has an H index of 40, you can be reasonably certain that they've published a lot and that their work has been fairly well received. Normalized citation impact is another performance metric about individual authors. And this is sort of like one level up from being a straight report of an author's citation count. So NCI, or normalized citation impact, is calculated by dividing that citation count by the expected citation rate for documents in the same document type or year of publication or subject area. So the idea with this number is that it gives you a little bit more context for who an author is, or what kind of work that they've done. It's not just they've published 40 papers in their lifetime, it's that they published 40 papers in their lifetime and they've got so many citations, and that places them in, say, the top 10% of authors in their field, or authors in their subject area, field. That's what I just said. Another performance metric you might be familiar with is journal impact factor. So this reflects the average number of citations received by articles published in the last 2 years within a given journal. So again, this is juxtaposing the number of publications with the number of citations, just like H-index and NCI. Also, this chart, I don't expect anybody to understand this chart right off the bat. This is a chart about H-index, and it is confusing. Even those of us who are very familiar and work with H-index a lot, it's still like, what is this trying to say? But the idea is that the author's papers are along the x-axis, their citations are on the y-axis, and their H-index is, again, where those two things converge. All right, our final category of metrics is structural metrics. This is the most abstract of all of our metrics. And unlike the other two categories of metrics where they're often just numbers, like journal impact factor is a number, these are often visualizations. They're not straight numbers, because structural metrics are about the connections between entities in scientific publishing. A couple examples are co-authorship networks or co-citation analysis. And the chart on this slide is an example of a co-authorship network. Again, this is from one of our reports for NOAA ocean exploration. So just to focus on the group in this graphic off to the right, I hope you can see some of the names in there. The biggest ones are Embley and Baker. So in this group, within this larger author network map, the size of the author's name reflects the number of papers that they've authored within this set. And the lines are the connections of co-authorship. And the darker the line is, the more papers those two authors have co-authored together. So just as an example, Baker and Riesing is sort of more off to the left. There's a pretty thick line between them, and both their names are pretty big. So what that tells you is that both of those people have authored a lot of papers and that they've collaborated a lot. To zoom back out to the entire graphic, the different colors of the way that the authors are grouped, those are often like subject areas. And you can see that there's not a lot of overlap between subject areas, except in maybe the yellow within the blue. There seems to be more overlap there, but the people in that first group that we looked at, Baker and Reesing, they don't really seem to collaborate much with anybody else in the chart. So again, this is just an example of a structural metric. Co-citation analysis is where we do something similar, but see, rather than being about authors, it's about what papers are cited together. And the idea with this is that, again, it tells you about the connections between either papers or authors or organizations or what have you. All right, finally, one last thing about these categories of metrics. All of these categories of metrics can be applied at different levels of publishing. So I talked a lot about author metrics, but there are also metrics for funding and research organizations and for journals like Journal Impact Factor. Additionally, many metrics are designed to be used at a particular level. So H-index is designed to be used with authors, Journal Impact Factor is designed to be used with journals. It doesn't really make sense to try and calculate the Journal Impact Factor for an organization like NOAA. That's just, you need a different metric for that. So now we get into the why. What's the point of all of this? I'm sure some of it is somewhat obvious, maybe, but the general idea is that bibliometrics adds quantitative insight to decision-making about scientific publications or involving scientific publications. You can make decisions based on vibes, but you probably shouldn't. And bibliometrics can help to be part of a larger story of evidence that you use when making a decision. I've got some examples of what these decisions might be here on this slide, like demonstrating the impact or importance of scientific research at different levels. That's sort of a really broad idea, but a sort of package of bibliometrics can be used in something like a lab review to show some additional quantitative information about the work that the lab has produced. In terms of like identifying potential research collaborators, that's a potential use for the map on the network map on the previous slide of co-authors. If you're publishing in a particular area and you would really like to collaborate with somebody who has a lot of publishing or a big impact on their field, you can look at a network map like that and see who those people are and determine from there maybe which ones you want to look into collaborating with. And then again, Journal Impact Factor is used to help you identify journals to publish in. There are other metrics that can be used for that too. But again, rather than just, doing what your advisor tells you or choosing a journal based on Googling best biology journals to publish in, you can do both of those things, but also looking at something like Journal Impact Factor can give a quantitative, it gives a number. It gives something a little bit more concrete to help base your decision on. So if you're going to use bibliometrics in decision making, you probably want to be sure that you're using them correctly. And since bibliometrics is about putting a quantitative measure to something that is pretty abstract, like the quality of scientific research, it is good to be careful about it. I'm not going to get into deep into this topic right now. If you're really interested in this, you should attend our seminar on Thursday, where my colleagues Sarah Davis and Keith Locantor will give you an entire presentation just on using bibliometrics responsibly. But I really wanted to make the point that it's important to carefully consider what you're actually trying to measure when you're using metrics for decision making. You need to consider what those metrics were designed to do and if that fits with what you're actually interested in knowing. And you need to consider exactly what the metrics are or are not communicating. As an example of that, if you're trying to measure the impact of an organization's publishing or a group of authors publishing, using metrics about the organization's individual researchers may not actually give you a whole lot of information about the group as a whole. If your organization has, say, 3 authors that have really high H indexes and the rest of the authors have like lower ones, what does that actually tell you? And does that give you information about the entire group? Or is that just, we've got 3-star researchers? So yeah, just an example. And finally, you really have to consider the quality of the data you're basing your metrics on. Bad data in means bad data out. So here at the library in our Bibliometrics program, our workflows and procedures were designed with replicability and reliability and reproducibility in mind. So we get data from a particular source that is widely used and regarded as transparent and trustworthy. This would be the Web of Science. And we do not use self-reported data. And we also don't use data from other sources that some people may find interesting, but we can't replicate their calculations, and we don't know where the data comes from, so we're not comfortable standing behind those numbers. So we use our data exclusively from Web of Science. And finally, our team thinks carefully about these questions when we create reports or when we're recommending certain types of metrics for use. So that's a nice segue into what our team does. So one of the main things that we do is we maintain a list of articles published and or funded by NOAA. Again, this comes from the Web of Science, and this is distinct from the NOAA Institutional Repository. Even though they sound kind of similar, the Institutional Repository has all kinds of NOAA publications, from journal articles to tech memos and program reports and all that kind of stuff. And the Institutional Repository is a true database. It holds the full text of these works and is meant to be a research tool. Our NOAA publications list is not that. It's just the list. And again, it's based entirely on data from Web of Science. So it isn't comprehensive, unfortunately. That's one of the trade-offs that we have to make when sourcing our data. When using Web of Science data, we are trading comprehensiveness for reliability, basically. Some of the other things we do with that data, with that's in that list, we create and publish reports of bibliometric data, and we can do this for anyone from individuals all the way up to the program or office level. The graphic on this slide is a sort of mock-up of our research impact report for individual researchers. We can also consult on improving research impact or other ways of investigating research impact. And as this whole campaign week shows, we also offer education in bibliometrics concepts and tools. But bibliometrics is not just for librarians. You as an individual, as a NOAA employee or affiliate, have access to the same tools that we do. You have access to the Web of Science if you're on VPN, or if you create an account on VPN, you can also log into Web of Science from any device, no matter where you are. The company that runs Web of Science, Clarivate, they also have a bibliometrics specific tool called InCites. Again, as a NOAA employee or affiliate, you also have access to that. You can go in, create an account, and start investigating bibliometrics on your own. Start investigating perhaps your own impact or that of your office or all of NOAA or whatever is of interest to you. Because InCites is a Clarivate product, it does use Web of Science data. And I think I forgot to mention, Web of Science does have some native citation analysis tools within Web of Science itself. So anytime you do a search in Web of Science, on the results page, I think off to the right, there's usually a link to a site, I think it's called citation analysis. And that will take you to a page where you can look at all kinds of data about the set of articles in your search results, whatever those were. Finally, the second thing, maybe most important thing you can do in terms of bibliometrics is to take control of the impact of your research. And in today's world, that is often linked to your online presence. In general, the more visible and accessible your work is, the more likely it is to be cited and used by other researchers. The bullet points here are a number of ways that you can do that. Like I said at the beginning, I have a whole slide about ORCiD next. So if you don't know what a persistent ID is, don't worry, I'll explain it. But in general, if you want to improve your research's impact, just make it more accessible. Make sure there are copies of your publications in the NOAA institutional repository, or that they're published open access. Make sure that any data or software or anything else that you might use or produce in the course of publishing those articles is also available online and linked with your publications. And finally, you can always share about your work on social media. I know that's maybe not so appealing in these days when Twitter has kind of gone downhill, but there's still lots of people out there doing that, and they're, you know, enjoying some success. So that's always something you can try. Okay, so finally, a little bit about ORCiD. So like I said, ORCiD is a persistent identifier. And a persistent identifier is just a fancy way of saying an ID number that is expected to stick around for a while. So ORCiD itself stands for Open Researcher and Contributor ID. It is a nonprofit organization that hands these out. There's a better way to say that, but that runs, it's a nonprofit organization that runs and assigns these ID numbers. One of the main purposes of an ID number for a researcher is to help distinguish them from one another. And names are not unique, unfortunately, and neither are like initials and last names. So sometimes it can be really difficult, not sometimes, a lot of the times it can be really difficult if you're searching for a particular author's work in, say, Web of Science or Google Scholar, that you can't be sure if you're finding all of their work or if there's some stuff in there that was written by a different, say if their name is John Smith, it was written by a different John Smith. But with ORCiD, if those John Smiths have ORCiDs and they've attached their publications to those ORCiDs, it becomes very easy to tell them apart and to say this paper was written by John Smith 1 and this paper was written by John Smith 2. However, when you create an ORCiD and you create your profile, you can also attach all kinds of other publications to it, not just your journal articles. You can also attach tech memos, conference posters or proceedings, book chapters, graduate thesis, anything else that you write. And you can also connect that profile to the organization you work for, such as NOAA. You can add your education, and you can also add peer review or editing work that you've done for journals. But to tie this back to bibliometrics, we love ORCiD because with an author has an ORCiD and has all their publications attached to it, it becomes very easy for us to do bibliometric analysis of their work. We can be sure that we are finding all of their papers, that we are getting the right information about all of their papers, and there isn't anything else mixed in there to sort of muddy the waters. And if you want to do bibliometrics about yourself, and if you want to have the best research impact information about yourself, having a persistent author ID like an ORCiD is the best way to do that. And also, once you get all your papers in there, then it's a central location where everything's listed and you don't have to maintain a list on your website or on some random Word document in your computer, or however people do it all kinds of ways. But we like ORCiD. We think it's the best way, and we think that it's also the most convenient for many researchers. That is the end of my presentation. I've listed some resources that you might want to check out here on this slide, and I'll have Katie send out the slides later so you can actually click these links. But please ask any questions now or contact us afterwards.
Thank you everyone for joining us today. I hope you have a safe and wonderful rest of your day. Please look for our emails for the rest of the week, extolling the responsible use of metrics, and then of course our second seminar of the week on those responsible use of metrics, Thursday at noon, and that registration link is in the chat. Thank you all, and I hope you have a wonderful day.
Thank you.